in order to provide you the whole summary of what we have just said, this is the last thing, is that I actually taken it out from this part, this light over here. Alright, you can just access it, but I'll just rearrange this one and this one over here, so it's easier for you to see and convey. Alright, so if you still remember back this stuff, alright, at this particular point, this is just a straight signal. As you go towards this side, this one will start to become a little going up. As you go more towards this side, this signal will become more and more unstable, right? Because it's going towards infinity. Now, on the other hand, if you were to go inside the left half plane, you'll start to become decay. Alright, decay in the slower speed. As you go towards more and more the left half plane, you'll decay in a faster speed. Alright, you're gonna become decay and decay easy, like decay in a super fast speed. This is for the sorry, this is for the real axis. Alright, now at this particular point, this is straight line. As you go up to this imaginary point at this when real is equals to 0, you'll see this trend, meaning this one will oscillate. So instead of this one, you oscillate. Alright, so you oscillate at the midpoint, something like this. Okay, so as you go further up into the imaginary axis, you oscillate more, right? The frequency is getting more and more, meaning your imaginary is frequency, right? So as your frequency value is getting more and more, this means that you're going to be more and more oscillatory, right? So now, if extend to, for example, like this, alright? In other words, if I were to talk about this point over here, alright, this is a combination of this one and the oscillatory part, because the imaginary it's oscillatory, while this one, if you go to this side, it's going to decay. So when you add them all together, it's something like decay plus oscillatory is equals to oscillatory decay, which is over here. So this one is when we're talking about the real going into the left half plane. This one is talking about the imaginary when you're going up to the oscillatory part. So the more you go, the more oscillatory it is, and therefore if you were to go further out, you'll have something like this, meaning you'll decay faster, alright, faster than this part. Same as this, if you were to go into this side, this one will actually decay, rise faster. So instead of this speed, it actually rose in a more faster pace if your imaginary is actually going upwards. Alright, so I hope that this is a pretty clear understanding for this part. Alright, and this is pretty straightforward. Now if you talk about this thing, then it's slightly a little bit more in depth, more abstract. Now I'll do that, I'll make things in terms of the lines, the imaginary, because as you know, the imaginary axis draws the circle. Alright, the more you go up, so for example, if you start out from this point, you're actually starting from this point over here. Okay, so therefore if I will do that, this means that when I plot, I'm gonna plot each of this point onto the side, and I'm going up, I'm gonna plot more and more. Okay, so the circle is a plot of the imaginary, so I'll just highlight this blue color one as this one. Alright, so that means that this imaginary line corresponds to this circle in a anti-clockwise direction. Alright, so I just draw anti-clockwise over here. So far so good. So now, you started off at this point. Alright, this point is flat, correct? And therefore if you look at it over here, at this point, this is also flat. Right? Same thing. Okay. Now, if you were to take a look, if you go to an imaginary axis, you're gonna have a flat stuff, alright, but however it's oscillatory flat, meaning it's somewhat like this, flat. So as you go out this point, this means that you're gonna plot over here somewhat, alright, although it's not exactly. So instead of flat now, over here flat now, you become more oscillatory, but it's still flat, something like that. And the further you go over here, that means your imaginary axis is going up, you're gonna become more and more oscillatory, but still it's flat. And further down, if you go towards the most extreme side over here, this is super oscillatory but flat. Okay, now we're gonna indicate the real axis, alright, the real axis as the green color one. And this green color one is in fact from here to here. Alright, why? As we say, this point over here is mapped onto this point, correct? So as further you go towards the left half plane, this means that you are going towards the origin of the z-plane. So you are going towards this side. So for example, if it goes towards infinity, then this graph over here is going towards 0. Right, this is the rule. Alright, as previously as mentioned in this graph, this one, as you go towards the left half plane, this one will decay in a slower speed. As you go further up, it will decay in a faster speed, and if you go towards infinity, it will decay super fast. Same thing, if over here, alright, okay, over here it is a flat system. Now if you were to go towards somewhat like a left half plane, because it's going now in towards the origin, alright, so therefore it will decay in a slower speed. As you go towards the more left half side, you will become more easily decayed or decay faster. And as this point is exactly when the left half plane is infinity, right? It's going towards infinity, and therefore this one will decay super fast, as you can see. Alright. Likewise, if you're going towards this side, alright, your graph at first is flat over here, alright, at the origin. And if you were to go towards the right hand plane, this graph will most likely be something like this. Alright, it decays kind of slow. Alright, it decays kind of slow, maybe somewhat like that. As you go further up, you decay, or you rise in a faster speed. Sorry, you rise in a faster speed. Alright, this is the axis lah, for example. And as you go more further up, you actually rise in a faster speed, something of that meaning. Alright, same as this lah. Okay, yeah, the slope is more steeper. Okay, now we're gonna now talk about the interaction between the imaginary and the real. Alright, so I'm gonna denote this point. Alright, I'm gonna denote this point as my red color spot over here. Alright, this red color spot over here. So at this particular point, I can assume that this is the particular graph. Alright, just decay slowly. Alright, so therefore at this particular point, this is somewhat like this graph. Alright, it's somewhat decay in a somewhat slow speed also. Alright, and as you plot out, you're gonna become more oscillatory, plus having the trend over here, right? So you have something like oscillatory with that trend. And as you go further up, you're gonna go further up, you have something like this, more oscillatory, but with the particular trend, right? This is the trend, plus oscillatory is equals to something like this, decay. Alright, this is exactly the same thing that we have said previously, and therefore as you go towards over this side, you'll become like this, super oscillatory. And if you were to go all the way up, alright, you go all the way up, you encircle and then you all come back over here. Alright, at certain point, alright, maybe at 2, for example, imagining at 2. Point 2, you'll come back here. Alright, and when it comes back here to this back to this origin, okay, it will, alright. So at this particular point is at the origin, correct? So when it rises again, you will go back another loop. So you loop back. So at particular point where it is 4, which is come back to this origin again, you loop again. So you keep looping and looping and looping, and this thing goes forever. Alright. Same as for this point. If I were to take a line that I draw over here, alright, I will be somewhat drawing a new circle, a purple circle that is larger than the 1. Alright, larger than 1, which is the stability margin. Alright, so as you can see, the same thing here occurs. If you're over here, then this means that it is over this point. So this point, this graph will something like this, alright, which is same thing as this. And as you go up furthermore, you'll become more oscillatory upwards to a more unstable side. So this point is somewhat same as this one, more oscillatory. Okay, so as you can see, the trend is somewhat a bit in depth. So just take note that I'm using the line. Alright, I'm using the line to represent the circle, as you can see. Alright, and the movement moving towards here is same as the real axis. Alright, so this is one key thing that I just want to convey, and the trend itself, I hope that this is pretty clearly explained. But not least, the damping factor. Alright, maybe we have a certain damping factor with a certain angle. Okay, so this particular point still is the same. Alright, at the -1 spot over here. Okay, and as you go up, you're gonna plot something like that at this point. So maybe I should plot a circle like this. Alright, this thing. So the higher the magnitude, I'm gonna plot. So this means that the more I go up towards stability, this means that I'm gonna go towards stability. Alright, more and more points over here reflects over here, and more points reflect over here. It goes towards stability. Okay, and as your degree, alright, as your damping ratio so-called increases, alright, I'm gonna assign in the orange color one. Let's say if I'm near towards the imaginary, so my angle is somewhat larger. Alright, this thing over here, I will have a line that is going in this manner. Alright, I'm gonna thicken this thing. Alright, thicken this thing. So same thing, each of the point I can plot and plot. I know this is more getting more and more tougher to see. I'll just thicken my. So it's this point, I'll just plot over here, and the more you go towards the stability side, the more stable you are. So it's gonna go in this trend. Alright, so the lower damping factor, meaning let's say this is 0.5, this will be 0.4, and then 0.3. The lower you go, the larger the curvature. Alright, the larger the curvature will be, something like that. Alright, and therefore you can actually see from this graph itself, it's the damping factor is decreasing along this side. Okay, so I hope that this is pretty good now, and I shall see you soon.